Welcome to this lecture, and in this lecture we are just going to talking about the function overloading in C++. Two or more functions have same name but different argument, as we know as overloaded function. So in this lecture you will learn more about the functions overloading. So let's see, we have void, and I'll just write here void same name function with integer a. Then we have integer same name function which is float a, and then void same name function which is integer a, and then double b. So we have same name functions, but we have the different arguments here. So functions refers to a segment that group code to perform a specific task. In C++ programming, two functions can have same name if numbers or types of argument passed are different. These functions have different numbers or type, or both of parameters are known as overloaded functions. Let us see that we have integer test, and then integer test which is the parameter which is a. Then here I just write float test which is a parameter of double a, and then we have the integer test which is integer a and double b, like this one, okay, like this one. So here we have four functions are overloaded functions because of argument passed to these functions are different. You can see here test, 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 and test, and here we have three functions overloaded. Okay, notice that the return types of all these four functions are not same. You can see here return types integer, double, integer, and double, and the overloaded functions may not have different return type, but it should have different arguments. You can see here a, integer a, double a, integer a, and double a. Okay, so double b. So let's see the example of that functions overloaded. So we have void display same function with different return type. Then I just write void display and void display. So here I just write float, and then integer and float. Okay, three functions name with different return types. Now integer main. Okay, so integer main right here which is the integer a and which is equal to 5. Then float b which is equal to 5.6. okay, so b which is equal to 5.6, and then we have the display functions right here, and the display functions, and I just passed the parameters or the arguments which is a, then display which is b, b, and then display which is a and b. Okay, and it is return 0. Now I'll just overload these functions here. Okay, now after that I just write void display, and the display here is integer variable, and now I just write cout which is integer number, and this is integer number, and then variable, it will print only the variable, then end line. Okay, so you can see here that will print this integer variable. Copy this code for float and float for integer variable and then float variable 2. So float variable 2 and integer variable 2 right here, and then it will print integer and then variable 2 and integer variable 1 and then float variable 2. And here I just write variable number 2, which is print float. Okay, and that will the variable. Okay, so it will print only the variable values in float. So variable 1 and then variable 2 right here. So here the display function is called 3 times different types of the numbers of the arguments. So the return types of all these functions are same but not necessary. Build this program and we have an error right here, which is void display an integer variable, and here we have end line and then error redefining the void type of integer variable. Yes, I just write here float. Okay, now just run this code. So you can see here first number integer 5, float 5, integer number is 5, and then float number is 5. You can see here these functions run 3 times. So the return type of these functions are same but not necessary. So this is the function overloading in C++. If you find any other problem regarding this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are just going to talking about the encapsulation in C++. Encapsulation is a process of combining data members and functions in a single unit called classes. This is to prevent the access of data directly. The access of them is provided through the functions of the class. It is one of the popular features of object-oriented programming language that's help in data hiding. How encapsulation is achieved in a class? So make all data members private. This is first step. The second step is create public setter and getter function of each data members in such a way that the set function set the value of data members and get functions get the value of the data member. Let's just see the example of the encapsulation. Like here I just write hash include a stream and then using namespace. Then here I just create a class of encap, which means that encapsulation, and here I just write private. So this is a specifier which is the name of private, and here I just write num, integer num and character ch. Okay, since we have marked these data members private, any entity outside this class cannot access these data members directly. They have to use gather, getter and setter function. Then I just write public and which is integer get num, and here is define the constant as a keyword. So return which is num. So here getter functions to get the value of the data member. Since these functions are public, they can be accessed outside the class and thus provided the access to the data member through them. Okay, and now here I just write character get ch. Okay, so get num and get character, which is the functions here, and then here I just write constant. Okay, now return which is ch. Okay, now here I just write void set num, this function. Okay, integer num as a parameter, and then I just write this this num which is equal to num. Okay, So now here I am just going to create the functionality to the setter function that they are called for assigning the value to the private data member. Okay, and same like this one for void set ch method. Okay, so set ch. Okay, set num and then set ch. Here's right character ch, and then same like our old code, this ch which is equal to ch equal to ch. Okay, now I just go to the main function, so integer main, and then here I just write in cap, which is en as an object. So I just better to copy this in cap as a class name. Okay, in cap and cn, and then here I just write en dot set the value to this number, or set the character to this number, which is a, and then en dot set num, and the numbers here are 200, and then cout, which is en dot get num, which is end line. Copy this code and paste it here, and here is write get ch, and then it will print the value of get ch, return 0. Now I just check the output, and here it is running the code right now, and you can see here the output for this code. So at the initial step, I just declare the header files and class name, which is in cap, and then class specifier, which is private. So since we have marked these data members private, and the entity outside this class cannot access these data members directly, so they have to use getter and the setter method. Okay, so that's why I just write get and the set method right here. Okay, then here I just define public as a specifier, and then these functions to get the value of the data members. Since these functions are public, so they can access outside the class, thus provided the access to these members through them. So that's why I just write get numbers and return types here number, and then get ch, then getter set method, and then here I just define, so here I just define get method and then set method. So this is the encapsulation in C++. If you find any other problem regarding to this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are going to talking about the abstraction in C++. Abstraction is one of the feature of object-oriented programming where you show your relevant detail to the user and hide irrelevant details. For example, when you send an email to someone, you just click send and you get the success message. What actually happens when you click send? So how data is transmitted over the network to the recipient in hidden from you, because it is irrelevant to you. You just only have the access to the front end, that you just simply send the data and then you just get the message, which is success message. Now I just see the example of the abstraction in C++. So here you just see I just write header file hash include iostream, then using namespace, which is the std. Okay, now here I just define the class for abstraction, so abt, and then I just define the specifier. So a specifier here is private. Now integer num and character ch. So by making these data members private, I have hidden them from outside world. These data members are not accessible outside the class. The only way to set and get their values is through the public function. Okay, so here I just define public and then void set values. So I just create a function name which is set values right here to get the values of these two. So integer n and then character c. Now here I just write num which is equal to n and then character which is equal to c. So I just defined two data types right here, which is a num is equal to n and the character which is equal to c. Okay. Now our abstraction is here. I just go to the integer main and then I just write here abt, which is our class name, and then ab is our object name. So ab dot set values, and the values here is 100, and then I just write which is f. Okay, so 100 is our number value and then f is our character right here. Now ab dot get, so sorry, I just forget to define one other function, which is void get values. Okay, and now here I just write cout, which is number is, and then here I just print only the number, and then end line. Now here I just write character is, and then print character. C is small here, and now our code for this example is completed here, and I just run this code. So we have an error right here, which is void get values and then the character c right here. So character which is equal to c. Yes, first I just define this get values function right here. So it will get the values of this function and then return 0. So I just did a little mistake here because I just already defined this character right here. So character which is ch is equal to c, and here too I just write ch. And now it is compiling and run this code. So you can see here I just get these two values. So here I just define the abstraction level. So the abstraction level of this class is in private. So I just make these two number and ch is private, and then access these members with public specifier, and then set means use two methods, which is get method and set method. Okay, and then get these two values with the help of this object. So the major advantage of using this feature is that when the code involves and you need to make some adjustment in the code, then you only need to modify the high level class where you have declared the member as a private. Since one class is accessing these data members directly to you, do not need to change the low level, means user level class code. Imagine if you had made these data members public. If at some point you want to change the code, you would have to make the necessary adjustment to all the classes that are accessing the members directly. Two other advantages of data abstraction are making the application secure by making data private and avoiding the user level error that may corrupt the data. And this avoids code duplications and increase the code reusability. So this is a simple example of the abstractions and the abstraction class in C++. If you find any of the problem regarding to this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are going to talking about the exception handling in C++. An exception handling is a problem that arises during the execution of a program. A C++ exception is a response to an exceptional circumstances that arise while a program is running, such as an attempt to divided by 0. One of the advantage of C++ over C is exception handling. C++ provide following specialized keyword to this purpose, which is try and catch. So try keyword represent a block of code that can throw an exception, and catch represent a block of code that is executed when a particular exception is thrown. Or you just say that a try block identifies a block of code for which particular exceptions will be activated, or a catch program catch an exception with an exception handler at the place in the program where you want to handle the program, and which is used as the catch as a keyword. Okay, so why we need exception handling? So we just need this for separation of error handling code from natural code, and functions method are handle any exception what they choose, and grouping of error types, like in C++, both basic types and objects can be thrown as an exception when can create a hierarchy of exception, object, group, and exception in the user namespace or the class, categorize them and according to the types. Let's just see the example of that exception. I just define the header files right here, then main function, and inside the main function I just define integer a and integer b, then cout, which is enter two numbers. Okay, then cin, which is a and b. Okay, here I just define the exception, which is try. So try is if b is not equal to 0. So here I just define that like float, which is div, and div which is equal to float, and which is a divided by b. So if this condition is not true, so print this logic right here. Okay, then if div which is less than 0, so throw exception to e. So e is using for a keyword which is exception, so cout, which is a divided by b, which is equal to, I just write here div. Okay, now I just go to the else block, and here I just write throw exception b right here. Okay, now I just write catch for catching these exceptions, so integer e, and then I just write cout, which is, I just write here exception, which is divided by 0, and close this code here. Now catch it again, which is the character of st. So here I just create a new variable which is character st, and then catch the exception of, here I just write division is less than 1. Okay, and this is also for catch sts. Okay, and now I just write exception for catch, and then here I just execute unknown exception. Okay, so this is unknown exception here, and now return 0. Okay, so here in this example the program is demonstrate how exceptions are handled in C++. The program performs divisions operations only. You can see here this will perform divisions operations. Two numbers are entered by the user with the help of the cin. Okay, and if the divided is 0, means if these numbers are divided by 0, is less than divided by 0, then the division by 0 will causes exception, so that will cause then exceptions right here. Okay, So which is thrown into the catch block, and this exception will throw to the catch block. And if the answer is less than 0, then exception division is less than 1. So that exception will be executed right here. So all other exceptions are handled by the last catch blocks, which is thrown unknown exception. So let's just see the output. And we have an error right here, which is the unknown exception, and yes, miss this print right here. And here it's in catch block, and that will return. So the error here is accepted declarations before this token, so I just remove this and this too, and then run this code. So you can see here enter 2 number 2 and 2. So you can see here divided it's 0, 1. Now here I just write the result, which is like 9 and 0. So you can see here this exception is divided by 0, so it will give us the result right here. Okay, now one another -1 and then 10. So you can see here division is less than 1, so that will give me the result of that. So this is exception handling in C++. If you find any other problem regarding to this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture we are going to talking about the polymorphism in C++. Polymorphism is a feature of C object-oriented programming language that allows the object to behave differently in different conditions in C++. So we have two types of polymorphism, which is compile time polymorphism and runtime polymorphism. This is compile time polymorphism, which is also known as static or early binding, and the runtime polymorphism, so this is also known as the dynamic or late binding. So the keyword polymorphism means have many forms. Typically polymorphism occurs when there are hierarchy of classes and they are related by the inheritance. Let's just see the compile time polymorphism, and in this lecture we just totally consist of the compile time polymorphism. So functions overloading and operator overloading are preferred example of compile time polymorphism. So here we just go to the example of that. So here I just write hash include and then iostream. Okay, now using namespace std, and here I just write a class of add. Okay, then public and integer sum. Here I just write integer number 1 and integer number 2. Okay, this is the function name, which is integer sum, and then the parameters are integer number 1 and integer number 2. Now return type is number 1 plus number 2. Okay, so this is the return type. Now integer sum again, and here I just write integer number 1 and then integer number 2 and integer number 3. Okay, so take 3 integers, and that will also a function name, which is sum, and then return number 1 plus number 2 plus number 3. Okay, now I just go to the integer main. So here we have the add is a class name, so AD is the object of that class. Now cout, which is output, and here I just write AD dot sum. So that will call the first function right here, which is 10 and 50 as a value, and then end line. Now output 2, and which is add dot sum. So here I just write 20, 30 and 50. So that will call the second function right here. Okay, and return 0. So now I just run this code. So you can see here first output is 60 and another output is 2100. Okay. Now you can see here that this example we have two functions with the same name but different numbers of argument based on how many parameters we pass during the functions call determines that which function is to be called here. This is why it is considered as an example of polymorphism, because in different conditions the output is different, you can see here, and since the call is determinant during compile time, that's why it is called compile time polymorphism. So if you find any of the problem regarding to this lecture, please let me know, and thanks for watching this lecture. Welcome to this lecture, and in this lecture you will learn about the C++ templates. You will learn to use the power of templates for generic programming. Templates are powerful features of C++ which allows you to write generic programs. In simple terms, you can create a single function or a class to work with different data types using templates. Templates are often used in larger code based for the purpose of code reusability and flexibility of the program. We have the two concepts in the templates, which are the functions templates and the class templates. The functions template, a function template work in a similar to a normal functions with one key difference. So this lecture is totally based on the function template. So a single functions template can work with different data type at once, but a single normal functions can only work with one set of data types. Normally, if you need to perform identical operations on two or more types of data, you can use functions overloading to create two functions with the required functions declaration. However, a better approach would be to use function template because you can perform the same task writing less and maintainable code. Let's just see how to declare a function template. To declaring a function template, you just need template as a keyword, and then class, and any class you just write class T, and then T, and you just write some functions right here, and then T arguments. Okay, and then start your code right here. So the template is the keyword here, and the parameters inside these parentheses is the parameters. Okay, let's just see the example of this template functions right here. I just copy this code, and here I just write template as a keyword, and then class which is T. So here it's a template function. So T dot, so T, and here I just write large. So large is our function name right here. So I just pass the parameters. So T and 1, sorry, T is a capital here. So T and 1 and T and 2. Okay, and it will return us N1 which is greater than N2. Okay, and N1 and N2. So this is our function here. Now I just write integer main function, which is int I1 and then I2. Now float F1, so float F1 and then F2, and characters C1 and C2. Now C out here, I just write enter to integer. Okay, and here is write end line. Okay, now Cn, which is I1 and I2. Now here is write cout, which is enter two float point numbers. Okay, and that will cin, which is f1 and f2. Okay, now I just write this for the characters. So after that I just write enter two characters, character, and then this is c1 and c2. Okay, now here I just write cout, which is the large function name here, which will print I1 and I2. Okay, and that will I just write here is integer and end line. Now same as a field like here and here. So this is f1 and the f1, and here is write float, and this is c2 and c1 and c2, and this is character. Okay, now return 0. So I just check the output. So we have an error right here, which is the token error, and now build again. So we have an error right here. Okay, and this is the large, and I1, this is I1 and then I2, and this is an integer and large, and I just make a little mistake right here, and build again. So yes, okay, and yes, our program. So enter two integers. So I just write 5, 10, then two float 5.0, 10 is a float, so I just simply write 10 here. Characters are k and k, so k is characters area, as you can see here. So in this program, a function's template large is defined that accept two arguments, which is n1 and n2 right here. You can see here n1 and n2 right here. So n1 and n2 is a data type of t, which is t is signifies that arguments can be of any data type. Large functions return the large amongst the two argument using the template conditional operator. So you can see here this is template conditional operator. Okay, inside the main function, variables of three different data types, float, character and integer, are declared. The variable are then passed to the large functions as the normal function. During runtime, when an integer is passed to the template functions, compiler knows it has generate a large function to accept the int argument and does so. Similarly, when floating data and character data are passed, it known as the argument data types and generate a large functions accordingly. This way, using a single functions template, replace three identical normal functions and made your code maintainable. If you find any of the problem regarding to this code or regarding to this lecture, please let me know, and thanks for watching this lecture.
Welcome to this lecture. In this lecture, we are going to be learn about the recursion in C++. When method or a function is called within the same method or a function is called recursion. The method which calls same method, it's called recursive method. In other words, when a method call itself, then that method it's called recursive method. Recursive methods are very useful to solve many mathematical problems like to calculate the factorial of a number and generating the Fibonacci series, etc. The advantages of recursion is method calling related information will be maintained by recursion and stack evaluation will be take place by using the recursion. In inf, infix, prefix, postfix notation will be evaluated by using the recursion. What are the disadvantages? It is very slow process due to stack overlapping. Recursive program can create stack overflow and recursive method can create as a loop. Now we see the example of this recursive method using the factorial numbers. And as you can see, I just write here the libraries of hash include iostream and using name space std. And then here I just define a method which is factorial and integer. Now int n and cout, which is enter a number to find a factorial. Okay, and here I just close this code and then cn, which is n. Now I write cout, which is factorial of and then n, and then here I just write is equal to. So is equal to is this function name, which is factorial. So I just pass a parameter which is n. Then return 0. Now integer factorial and integer n, and then if n is greater than n, so return n steric factorial, which is n minus 1. So this is a factorial formula, and go to the else condition. So else is return 1. Now just execute this and you can see here 20. So factorial of 20 is minus 21 and up to this number. Execute it again and 2. So the factorial of 2 is 2. So as we look on the factorial formula, so I just take a function name here, factorial, and which is the integer n as a parameters. And if this condition mean n minus 1 is true, so it will give us the result as a factorial. Otherwise, it will give us a return 1. Now, we see how we call this program as a recursive. So you can see here, I have a function name, which is the recursive function. Then in the main body, you can see here, I just call the function as a parameter. So here I just call this function. So it is the recursive function what I called here. So this is also the recursion, and the recursion is if n is greater than 1, and then it is the result of n steric factorial n minus 1. Suppose that we have the number 3 in this n. Okay, so factorial function tests the expressions inside if else statement. Means if statement factorial function tests the expressions while it is true, means this function is true. The return n steric factorial n minus 1 statement execute when called the second factorial functions and the argument passed is num minus 1 which is 3, means this our value n is 3 here. So it will give us the result of this value. So this is a simple example of the recursion in C++. Thanks for watching this lecture. See you in next lecture.